Please introduce yourself and tell us why you're attending EMEX this year.
Hi there, my name's Andy Sumner. I'm the Commercial Director for Future Motors, and we're at EMEX to spread the good word about our proposition. We think it's the right audience and the right people, and we think it's the right time. Future Motors, we're a distributor for a Silicon Valley-based company called Turntide. And Turntide have developed something called a switch reluctance motor, which in a nutshell is a software-driven motor that is significantly more efficient in its consumption of electricity than traditional motors. And its application is in heating and ventilating, so HVAC, and in pumps. And so it's pretty topical for EMEX in that it can reduce an organisation's electricity consumption, somewhere between fairly and very materially.
What are your customers' main concerns at the moment?
Firstly, there are two drivers at the moment that most of our customers are talking about. In no particular order, the drive to net zero and decarbonisation, and we are on the demand side rather than supply side, and there aren't that many options on the demand side. The second one, of course, is we're in an energy crisis. Energy pricing, electricity pricing has anywhere between tripled and quadrupled for most organisations over the last 12 months. And our proposition, we know, can make a very big dent in a building's electricity consumption.
What role do motors play in a building's typical energy consumption?
There's not a huge amount of knowledge I've found about the amount of energy motors consume. So if you take a typical office building, then 40% of the electricity the office building consumes is in heating and ventilating, so HVAC. Of that, 50% of that energy is in fans, in motors, driving air around the building. So typically a building will spend 20% of its electricity on electric motors that drive air around the building. Our proposition can save anywhere between 30 and 60% versus traditional motors. So you work that math through, somewhere between 7 and 20% of a building's electricity consumption can be reduced by installing our proposition. It's sort of a hidden, a hidden consumer of electricity that most people generally aren't aware of.
Can you tell us more about the technology behind smart motor systems?
The software really carefully controls the operation of the motor and only delivers the minimum amounts of electricity required for that motor to do the work, to drive the fan, to drive the water that it needs to do. And it's constantly monitoring the amount of electricity that it's. So it's really smart. It's called a smart motor system, surprisingly, I guess. But the switch reluctance motor, which is the technology, has been around for ages. It's the software and the power electronics that we've developed, which make it infinitely controllable and therefore significantly more efficient than any other motors that are out there on the marketplace. What we find with a lot of air handling units is they're not very smartly monitored and managed. Our motor integrates with pretty much every BMS, but also it can be attached to things like CO2 sensors or temperature sensors. So it can proactively slow up and down depending on the environment, controlled either by the BMS or B by sensory influence. And so what we found, and I'll give you for instance, we rolled out our solution to all the Wilko stores in the UK. The motor itself saved them 40% of their electricity consumption versus their old motors. But when they hooked that up to the BMS and smartly configured it, then that 40% went up to 60% saving. So there are two elements. Firstly, there is the inherent efficiency of our motor, and then secondly, the controllability. Add those two things together, and it really does make a material impact on electricity consumption.